Welcome back. This is Limit Techniques. I'm Dr. Joseph, and what will we be doing today? So you've learned evaluating limits can be tricky. In this video, we'll see a few techniques to solve some of those trickier limits by hand. And we'll also be using continuity as we do this. So the definition of continuity is here again. It's an important one. All right, let's see what to do here. So the point of using this, or how we're going to use it, is that if we know our function's continuous, then limits are easy because the limit is just the value of the function, right? So if I have some complicated function here, I don't want to think about using the limit laws, all those different steps. But if I can show f is continuous, all I have to do is plug in a, and I'm good to go. Okay, so there's going to be three basic types of these problems, and some of them involve factoring. We already had an example similar to this a while ago, but that was when we were thinking very by the book about limits of sequences, and we want kind of a faster way. So let's see, can we factor the numerator? Of course, yes, we can. It's x minus 5, x plus 1. And so as we're approaching 5, the value at 5 doesn't matter, and therefore it doesn't change anything if I cancel these terms. Think if x were a number close to 5, like 5.1, then this would be 5.1 minus 5, and that would be 5.1 minus 5, and I could just cancel them as numbers, right? So this tells me that the limit I started with is equal to this limit of just x plus 1. As x approaches 5, x plus 1 is a polynomial. We know those are continuous everywhere. So I can just plug 5 in for x. The limit is 6. Okay. Example 2, combining. So I want to, well, first I can see these look like rational functions. Those are continuous where they're defined, but here I can't plug 3 in, right? 3 is not in the domain of that function because I get a 0 denominator again. So I need to sort of combine, put them together. I could try to get a common denominator now, but it's going to be much easier if I could factor that denominator first. Which might not always be the case, but it is here. That denominator is x minus 3, x plus 1. So then that is my common denominator. And to combine them, I just need to multiply that first fraction by x plus 1 over x plus 1. So I haven't really done anything with the limit yet. I'm just making an algebraic manipulation. And now that I have a common denominator, I will combine. So x plus 1 minus 4 is x minus 3. Now we're in the situation we were in the previous example where we can cancel these terms. And we have the limit of 1 over x plus 1 as x approaches 3. Now, this function here is a rational function. And so it's continuous on its domain. And that means I can just plug in the number 3. So how did I do this last step? It's because 1 over x plus 1 is rational, therefore continuous at 3. So that's where we're using continuity. I don't want to go back to the limit laws. That takes too long, right? Okay. Last example. This is called the conjugate trick. And again, it's a case where I can't directly plug in the value because I would get a 0 denominator. So this is something you wouldn't know to do unless you'd seen it before. If I multiply by square root of x minus 1 plus 2 divided by itself, it's important to have it in the numerator and the denominator so that I'm not changing the value of the functions. And so what was the benefit of that? Well, the numerator now of this new fraction is a difference of squares. Remember, like a minus b, a plus b is equal to a squared minus b squared, right? So the square root there is the a. So the square root gets squared, that becomes just x minus 1. And the b is 2. So I get x minus 1 minus 4, a squared minus b squared, divided by, now my denominator is going to look a little messy. I have x minus 5, and then I have the square root of x minus 1 plus 2. It's important to use parentheses there. All right, great. So let's simplify a little bit. We have x minus 5 in the numerator. And what luck, that cancels the x minus 5 in the denominator. Now, again, here I could finish this out with a whole mess of limit laws, but we don't have to because we know this is continuous. Because it's a combination. Let's just say it's a combination of continuous functions. Go back to the continuity day 1 video if you don't know what I'm talking about. Square root's continuous, dividing is continuous, adding, subtracting. So this is going to be continuous where it's defined, and it's defined at 5. So I'm allowed to just plug it in here and say the limit is f of a. So I've got square root of 5 minus 1 plus 2. And now I'm just doing arithmetic. Square root of 4 is 2. So the answer is 1/4. All right. So here's a few examples for you to try, one of each type. Again, they were factoring and canceling, combining, and the conjugate trick. And here are the answers. All right, so make sure you can compute those before class. And next is the intermediate value theorem.